Welcome to Rajashekhar classes on Applied Data Science with Python. This is lecture number 398. In this lecture, we will try to understand constructing a decision tree. Since we learned a bunch of concepts like entropy, information gain, and Gini impurity, we will use all of these concepts to learn how to construct a decision tree. So, when you construct a decision tree, actually we construct in top-down approach. We start at the very top, that is, let me say here, we are starting at Outlook. Is it not? Is it not? Just say we will start at very top, means in this context, in this particular construction, we will start with Outlook. I have a data set D with 9 positive points. Just see, S means what? Positive points. And 5 negative points. No means what? Negative points. So, entropy with respect to my data set capital D for a random variable Y, which is my class label. What is my class label here? My class label is play tennis. This is random variable Y. This is also known as class label, isn't it? Now, this is entropy with respect to my data set capital D. This entire thing is data set, isn't it? My data set capital D for random variable Y, HD of Y. Let me say, what is HD of Y? H means what? Entropy. Whose entropy? Of random variable Y. Which one is random variable? Y here, class label Y. This D is data set, entire data set. We already calculated. We know how to find entropy. We already discussed in our previous lectures. What will you get? How many positive points? There are 9 positive points. 9 by 14 into log base 2. 9 by 14 minus 5 by 14 into log. What will you get? You will get totally 0.94. I can break data set by using any of the 4 features. What are the 4 features? 4 features are Outlook. What are the features here? You can break the data set by using any of the 4 features: Outlook, temperature, humidity, windy, isn't it? Here, let me assume, I can say, well, let's assume I selected Outlook to break my data set. When I break it using Outlook feature, Outlook have 3, what is this? 3, Outlook has 3 possible values, 3 categories. What are they? They are, just see, Outlook, which categories does it have? Sunny, overcast, rainy. Just see, sunny, overcast, rainy. Isn't it? What are the categories of this particular Outlook data set? These are the categories. What are the categories? Yes. Okay. Sunny, overcast, rainy. Isn't it? Now, when I break my data set using the Outlook feature, I get 3 data sets. What is my first data set? This is my first data set D1. This is my second data set D2. This is my third data set D3. For each of these data sets, I can compute entropy, isn't it? This is H means entropy of class label Y for data set D1. This is H of Y D1. This is H of Y D2 means entropy of class label Y for data set D2. This is entropy H of Y. This for which data set? For D3. We already discussed it. We have seen how to calculate, isn't it? So, I will compute weighted entropy. We know how to calculate weighted entropy. This also I already discussed in previous lecture. I have total data set here. What for total data set H of Y? H means entropy of Y with respect to D is 0.94. Just we have seen in our previous slide also, isn't it? When I break it up into 3 parts, D1, D2, D3, I can compute the entropy of D1, I can compute the entropy of Y with respect to D1, that is H of Y D1. Similarly, I can compute entropy of Y with respect to D2. I can also compute entropy of Y with respect to D3. And if I do weighted sum of all these entropies, weighted entropy, what will you get? 0.69. Just try to recall what we discussed in our previous lecture also, isn't it? For example, outlook has value. What is outlook value? Outlook has sunny, isn't it? Just how many possible values for sunny? Just see, 1, 2, 3, 4, 5 possible values, in which one is positive, which one is negative. For how many negative points for class level? 3 negative points. How many positive points? How many positive points for sunny? Just search for positive points in sunny. There will be positive means what? Plus. Positive means yes. Negative means what? No. You can find 2 positive points, 3 negative points. In similar manner, for overcast also, you can find 4 positive points and 0 negative points. For rainy, you can find 2 positive points, 3 negative points. Just try to recall what we discussed here. How can I calculate weighted? How can I calculate weighted entropy? Just try to recall our previous lecture. Just the number of sunny days. How many sunny days are there? There are totally 5. That is 5 by total number of days 14. This is weight. And what is its corresponding entropy? Just try to recall. We calculated this entropy in our previous lecture. Just recall lecture number 396 where I discussed all these things. That is 0.97. Again, what about second one? Well, this one is number of overcast days. How many overcast days are? 4 overcast days, total 14. Corresponding entropy, just try to recall, this entropy is 0. We already discussed. And what about third one? Number of rainy days, total number of rainy days are 5 by total number of days 14 into corresponding entropy 0.97. What will you get? 0.69. This is weighted. This is known as weighted entropy. How can I calculate reduction in randomness? What is this reduction? Reduction in randomness. Reduction in randomness is entropy at source, that is 0.940. Entropy at branches, what is entropy at branches? 0.69, that is weighted entropy. You are getting 0.246. This is approximately, I can say, it is 0.25, isn't it? We know how to calculate. This information gain. This is information gain. Information gain. In similar manner, actually, what are the features? Now we split our data set by using which feature? Outlook feature. In similar manner, you can always split this data set by using temperature, by using humidity, by using windy. Isn't it? It's the same procedure one can follow. Just if I say, but if I split this particular data set by using temperature, what are the possible categories for temperature? Hot, mild, cool. That's what I am writing here. What are the possible features? Hot, mild, cool. Isn't it? What about hot? Hot, if you observe carefully, what are the total number of values for hot? Just see, 1, what is hot? 1, I can say like this, just see. How many? Let me count. Yes, hot 1, 2, 3, 4. There are 4 possible values for hot. Out of these 4 possible values, how many no's for class level? There are 2 no's, 2 yeses. Therefore, I am writing 2 plus 2 minus. Isn't it? In that manner, I can always find mild. How many mild? There are total 6, in which 4 positive and 2 negative. And I can always calculate cool. There are 3 positive labels for cool and 1 negative label. I can always find entropy of Y. Entropy of Y means plate N is with respect to data set D1. This is my D1. And entropy of Y with respect to D2 we can find. Even I can always find entropy of Y with respect to D3. You know how to find all these entropies. I can compute these entropies. In similar manner, we can split data set by using humidity. There is other feature. What are the other feature? You can also split this particular thing by using humidity. This is humidity. What are the possible values for humidity? There are two high and there is a possible value normal. For high, how many S's and how many no's? There are 3 positive, 4 negative. For no, how many positive, how many negative? 6 positive and 1 negative. Isn't it? Anybody can understand this. Now what happens? Now what happens? What we need in at the end of this, you can split the same data set by using windy also. How many positive points for F means false and T means true. There are 8 points for false, in which 6 positive points, 6 plus means 6 yeses and 2 no's, isn't it? In D, now you can calculate information gain. How can I calculate information gain? Yeah, I can calculate information gain of label, class label Y with respect to Outlook. This I already discussed. We know how to calculate. We already calculated this 0.25. In similar manner, I can always calculate information gain of Y with respect to this value. I can calculate. Even I can calculate information gain of Y with respect to humidity. Information of gain with respect to windy, I can calculate. I have these four information gain values. That is information gain of Y with respect to Outlook, with information gain of Y with respect to temperature, information gain of Y with respect to humidity, isn't it? You pick one which give more information gain. We have to pick one which you have to pick one which gives more information gain. More information gain. If you observe, you will get this is a maximum information gain. You will get some number here, you will get some number here, you will say, but out of all these numbers, let me assume this you will get 0.25 is the maximum. All other information values are less compared to this information gain of class label Y with respect to Outlook, isn't it? I will get Outlook as my first variable. I have tried to break. I have tried to breaking with all the 4 features: Outlook, temperature, humidity, windy, and best one I pick using the one which has maximum information gain. When I pick Outlook, I will get 3 data sets. Why am I picking Outlook? I'm assuming that actually you will get Outlook more value compared to temperature, humidity, and windy. When I have my data set D, now I have as I'm getting maximum value for Outlook, now I have to break the data set capital D by using feature Outlook, isn't it? When I choose Outlook to break data set, what are the possible values for Outlook? As we discussed, there are 3 possible values: sunny, overcast, rainy. Yes, in the case of what is this overcast, just if you observe carefully, what are the possible values for overcast? Your label is yes. For overcast, label is yes. For these are the overcast values. Just see, this is 1, 2, 3, 4. There are 4 possible values for overcast. All of them, just see, all of them for class label yes. This is 4 positive and 0 negative, isn't it? 0 negative means this is dominated class. What does it mean? This particular node is known as, what do you call this node? As pure node, isn't it? In my D1 I have 2 positive and 3 negative, D2 4 positive, 0 negative, and my D3 2 positive, 3 negative. Now if you notice here, let's take D2. We have only positive points. This is important. Here we have only positive points. In the case of D2, we have only positive points. We have no negative points. No negative points in the case of D2, isn't it? See, remember, what is the objective of decision tree? Given a query point xq, what does it we have to find its corresponding yq, isn't it? If your outlook equal to overcast, just see, if your outlook is overcast, just see, if your outlook, this D2 is known as pure node, isn't it? Why? Because it has got only one class labels. If your Outlook, just see, if your Outlook, these are the values of Outlook. Outlook has got different possible values. What are the possible values? Sunny, overcast, rainy. If its Outlook is overcast, you are getting pure node. D2 is known as pure node. Why? Because it has got only positive labels. There is no zero negative labels, isn't it? So if your Outlook is overcast, in my training data, all the points are positive. All the points, zero negative points, all the points are positive. Such a node here is called as pure node. This node D2, this node D2 is known as pure node. Why? Because it has got only one type of points, positive points here, because it has only one class label and does not have the other class labels. There is no need to breaking it further. There is no need, isn't it? No need to D2, no need to break it further. No need to break it further. That point is important, isn't it? Here in D, I have 9 positive points. What is my data set? In my data set, just observe here, how many? 9 positive points and 5 negative points. Here in D2, I have 4 positive points and 0 negative points. So I can stop here. Why? Because my D2 is pure node. Therefore, I must stop here, isn't it? I must stop here. Just see this Outlook. Outlook is as overcast value. Outlook value is overcast. Overcast means all positive points. All points are positive means just I must say yes. This is my data set D2. I don't have to go to any further at this point. What about my D1? D1 I have 2 positive points. Just see this D1. D1 has two positive points, 3 negative points. I need to still break it further. At D1, I have to check temperature, humidity, windy. Why? Because already Outlook is completed. Now here you have to check. What you have to check? I have to check which features we have to check. We have to check temperature, humidity, and windy, isn't it? Now I need to compute information gain. So what happens is humidity is a feature which gives you more information gain. Let me assume we know how to calculate information gain by splitting with temperature, by splitting this particular data set D1 by using, let me say this is D11, this is, let me say, D12, this is, let me say, D13. I am splitting this data set D1, this is data set D1. I am splitting this data set D1 by using features like temperature, humidity, windy. Why? Because overlook already completed. Let me assume now I need to compute information gain. So what happens is humidity is a feature which gives you more information gain. If you calculate it, humidity is a feature which gives which gives more information gain, more IG information gain. Just see Outlook, my data set, this is D1, just humidity is if I split data set D1 by using temperature, humidity, windy, temperature and windy will get less information values, less information gain values. Therefore, I must choose humidity as a feature here, isn't it? Now, what you have to do? Just see 1 minute. Just see here. In second data set D2, what happens? The second data set, anyway, it's a pure node, isn't it? 4 positive, 0 negative. This is pure node. We stop here because this is pure node. If you need not bother about D2. That's what we are discussing. If data nodes has only positive points or negative points, there is this only positive. If particular data node has only positive points and only negative points, those nodes are known as pure nodes, as we just discussed, isn't it? What about this 2 positive and 3 negative case? This case, 2 positive and 3 negative. Let's take a data set. What is the data set? What is the first one? This is sunny. How many sunnies are there? How many sunnies are there? There are 5 sunnies. There are 5 values. These are 5 points. Just see 1. Just you can count sunny 1, 2, and 3, 4, and 5. You have 5 sunny values. Therefore, just see the table in which how many positive points? 2 positive points and 3 negative points, isn't it? 2 positive points, only sunny rows you have to check. Now, if you break it by humidity, why? Because I am assuming that this humidity information gain value is more compared to temperature and windy. Is if you break it by humidity, let's see what happens. Now, humidity can be higher or lower. Just check. Just see, humidity is, what are the possible values for humidity? Yes, just see humidity. First, what's the case here? Here we have sunny. In sunny rows only you have to check. In sunny, next we calculated here humidity, temperature. What are the features here? Humidity, temperature, windy. Here, in which we realized that here you are getting humidity information gain values more. For humidity, what are the possible values? Just see. I have high as well as normal. How many highs are there? 1, 2. Just check this highs. Humidity, high, high, high. What are the possible values? No, no, no. Means no means negative. You are getting 3 negative, 0 positive. All are positive point. All are negative point means it's a pure node. In similar manner, just count normal. This just say normal. How many normals? 2 normals. What are the possible corresponding possible labels for this? This is normal S. This is normal S. How many S's are there? 2 S's, 0 nodes. Means this is also a pure node. This is also pure node. This one is also pure node. Just if you recall, just see what's happening here. Humidity. For humidity, what are the possible values? Only we have humidity high and normal, isn't it? For high, what you are getting? For high, only you are getting negative points. Therefore, I am saying no. And for normal I am getting only positive points. I am saying yes. In similar manner, you can also split this particular data set, that is D3. This is data set D3. Here also you can calculate information gain. If you calculate information gain, you will get wind has more information gain. This wind has 2 possibilities. If you go through it, just see this wind has two possibilities. Windy. One is false and another one is true. False means weak, true means strong, isn't it? Now, in this manner, you can construct a decision tree. After constructing decision tree, you can always check if there is some query point. Let me say when what you are doing here effectively is basically you are recursively breaking each node. We are recursively, what we are doing here, we are recursively breaking each node using information gain. As the criteria. What is the criteria here? Information gain is the criteria. Why is the pure node good? What's the reason? Look at, when you have a pure node at the end of a decision tree, I have pure nodes. What are the pure nodes here? Yes, pure node, no. Pure node, no. Yes, pure node, pure node, pure node. These nodes are pure nodes, isn't it? Once I have pure nodes, it follows this path. For example, let me say for any query point, when outlook is sunny, let me say there is a query point, outlook equal to sunny. Outlook equal to sunny and humidity equal to normal. What is the class label? What is the whether you class label is Platonist. Outlook equal to sunny. This is outlook. This is sunny. Outlook equal to sunny and humidity equal to normal. Humidity equal to normal means this path, isn't it? In this path, what happens? It says yes. If I in my data set, whenever outlook is sunny and humidity is normal, the result was always yes. There was no tie, and it's not about majority. All the points in my data set, wherever the outlook equal to sunny and humidity was normal, I have my class label as yes, and that's what this decision tree says. I request you to go through, this lecture once or twice, so that certainly one can understand. If you have any difficulty, please keep a comment. I will continue my discussion on constructing decision tree in my next lecture also, that is in lecture number 399. Thank you very much.